Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And as we lead up to Kubecon, we actually wanted to get a very specific guest on the show for this week. We're going to be an interesting topic. We're going to be talking about virtualizing Kubernetes. And for that, we have Lukas Gentele, co-founder and CEO at Loft Labs. Lukas, first of all, welcome to the show and give everyone a quick introduction, please.
Awesome. Yeah, glad to be here. Thanks for the invite. As you mentioned, KubeCon's coming up next week, so really excited about that. I'm Lukas, one of the co-founders and the CEO at Loft Labs. We started the vCluster open source project in 2021. And ever since, we've been working on virtualizing Kubernetes for the past couple of years. It's a really exciting journey, and yeah, happy to dive into the topic with you.
Fantastic. Yeah, and it'll be interesting too because a lot of our listeners have a background in virtualization and VMs, and then they have a background in Kubernetes and cloud native technologies. And so let's get the most obvious question out of the way right up front. Like, why virtualize Kubernetes? Like, why not just do bare metal? Like, in my mind, I can see advantages, just like there was with virtualizing of VMs, but I could also see like, hey, it's another abstraction layer and you got to manage this, and that's more complexity, right? So I'm sure you get that a lot. What's your thoughts?
Absolutely. I think that's one of the most common questions, right? It's either, isn't Kubernetes already virtualized in a way that you can run it on VMs, right? Or the other question is, why do we need another layer, etc.? Does it have any latency issues or performance hits and, these kinds of questions. Probably similar than, what people, that discovered Docker in the early days and were kind of like advocating for Docker. They probably got similar questions, right? Because, VMs are already around, right, as an abstraction layer. Why do we add something on top, right? I think the main reason for why this is important is when you think of the early days in Kubernetes, Kubernetes is really designed at its core to be a large-scale distributed system. And it ties together all of these VMs in a cluster. And that's great. And the overall promise is that Kubernetes can distribute workloads and it can increase utilization across these nodes, right? And it was really designed from day one to be this large scale system, right? People remember the Borg story and like Google having this large Borg system, right, as kind of an inspiration for Kubernetes. And in the early days, if people remember, maybe 2017 and these kind of timeframes, right, it was about how big can Kubernetes get? How many nodes can the scheduler handle, right? First, it was like maybe 100 and 200, then it was 500, then it was 5,000, right? But somewhere along the way, we've forgotten about that Kubernetes is designed to run at that scale and really highly optimized to run at that scale. And we started to build these 3-node and 5-node little clusters for this dev team and for this staging environment, right? And so a lot of enterprises today, when you ask them how many Kubernetes clusters they have, when you ask Google how many Borgs do you have, you don't get the answer 5,000, right? The whole goal is to have like a large system that distributes the work for you. And the goal of a scheduler is not to balance 3 VMs, right, and 3 EC2 instances in AWS. You could kind of do that manually, right? What Kubernetes is really great at is if you give it 500 VMs, right? But most companies today, if you ask them how many Kubernetes clusters do you have running, you either get the answer, we don't really know, which is already a bad sign, right? Or you get the answer, 200, 500. The biggest one I've heard is way over 3,000.
Wow.
Clusters in
Wow.
AWS. Those
Yeah.
are big numbers, right? And there's a lot of inefficiency if you're running all of these little clusters because exactly that utilization problem, right? When you think of a VM, if you give every team and every application a separate VM, then that VM is highly underutilized. Well, now we have Kubernetes that can balance workloads, etc. But if we end up giving everybody one Kubernetes cluster that consists of 3 VMs, we actually didn't solve the problem. We actually 3x the utilization problem, right? We just made it 3x worse, right? And we looked at that scenario and we're like, why are people not creating these big clusters? And what we found out by, just talking to operators that run these big clusters is that multi-tenancy is really hard in Kubernetes. The same way as, and people say, we have namespaces, we have RBAC in Kubernetes, right? We have obviously users and groups. And people ask me like, isn't it possible to just share a cluster with, what's in Kubernetes today? And I'm always saying, well, technically in Linux, you also have users and you have folders and you have fine granular permissions on every file and everything, right? But without virtualization, sharing a bare metal machine is incredibly hard. And the same is true for Kubernetes. And that's why we're like, can we take this pattern of virtualizing a bare metal machine and apply it to Kubernetes to actually make multi-tenancy work? And the result of that is vCluster and the idea of the virtual Kubernetes cluster.
No, I love that. That's super helpful. Thank you. And let me ask you this, because what I kind of see is like there's lots of parallels from like back when we had physical servers and then we went to virtual servers and then we had went to containers and then we had Kubernetes, and like it's always these common themes of like, okay, segmentation of resources versus efficiency, if you will, right? And but there's always that moment where you have to have that conversation with somebody, and you got to get the light bulb to go off and make that connection of go, okay, that's actually worth going to the trouble to re-architect other things. Because especially with Kubernetes, I feel like a lot of folks, once they get it up and running, like they don't want to touch it. And so like it tends to be a little bit like, hey, I don't want to be messing around with this too much, right? And so what are some of the most common, I'll use the term use cases, or what is the most common ways that folks kind of get to that realization? Is it as simple as combining test and dev and production environments? Or like when you talk to customers and they have like, hey, I've got stuff everywhere, like where do they start?
Yeah, that's an excellent question. Uh, we're not telling people, we don't have the illusion, right, that you have one Kubernetes cluster, one giant Kubernetes cluster that spans the world and all your business units and teams and 20,000 people access that at the same, right? Like that would be a little bit utopian to assume that that is ever possible, right? There's obviously also physical constraints between, latency constraints, literally like the wires in the ground, right? And latency between different data centers, etc. But maybe you don't need 3,000 Kubernetes clusters. Maybe you can get away with 10 or 20. And then you spin up these virtual clusters on top. To your question around where to start and what are the use cases. So I think we tell people if you have a large fleet of Kubernetes clusters, your goal is probably not at first to migrate 500 clusters next week, right? And that's probably the wrong approach. That would be awesome if you could, wave a magic wand. The first thing I always tell people is look at how many clusters will you need to spin up with the current approach in the next 12 months? And how about you stop doing that? How about you start handing out virtual clusters instead to kind of, reduce the leaky bucket kind of problem, right? You're not making the problem worse from here on, right? And the easiest case, to start with is obviously pre-production. The hurdle in production is much, much higher in terms of, migrating things, in terms of security constraints, in terms of so many people need to approve things, right? But when you in your organization today have, let's say 10,000 engineers and you have 500 Kubernetes clusters and Kubernetes is the platform you're moving towards, more and more workloads will be spun up and more of these 10,000 engineers will need a Kubernetes cluster. So if you were to make that offer tomorrow, would that bankrupt your IT budget, right? If the answer is yes, then you probably want to make the offer to hand out virtual clusters. And, predominantly dev environments, ephemeral CI environments, staging environments are great cases to start with. But we've seen a lot of success with virtual clusters in production scenarios as well for, like spinning up a cluster per customer, for example, but also for internal production cases. So let's say you have internal tools like your GitLab and those kind of vendor tools running internally, and you have them running 20 times for 20 different business units, for example, right? It's a great case to say, let's move to a multi-tenant cluster rather than spinning up individual separate clusters. And leading up to your question, you actually mentioned something really interesting as well, and that's re-architecting, the need to re-architect things. One of the things that we're really proud of is that we're a certified Kubernetes distro. That means we pass all the CNCF's conformance tests. And that's really important because we want to tell people when you hand out a virtual cluster to your engineers in your organization, right? We usually talk to the platform team or to the central IT team, and they hand it out to these engineers. We usually tell them, you may not even need to tell them that this is a virtual cluster, because ideally they shouldn't even notice that this is any different than the regular GKE, EKS, or private cloud cluster, right? Because we pass all these tests, and that means they don't have to change anything about the application. They don't have to change anything about the way their CI pipeline works or, their kubectl or Helm, right? All of these commands stay exactly the same. All of the tools, these, 5,000 tools you see on the CNCF landscape, right? Everything is still usable in a V cluster, right? With very, very, very few exceptions where you need to tweak something a little different, right? Maybe like 5 tools you can really count it probably on one, maximum 2 hands, right? The tools that need something special for a V cluster. And those tend to be the tools that work directly on networking and hardware related things, right? That are going quite deep on the node. But typically a V cluster works just like any other cluster. And the only thing you do is instead of talking to this real cluster, you now switch your kube context and talk to the virtual cluster. That's the only change you need. And that's a pretty nice way to kind of migrate over to virtual clusters.
Yeah, and a follow-on question, but also an observation too. Yeah, as somebody who in previous roles at other companies, I dealt with CNCF and that certification of distributions. I mean, it is so nice to have that, and it's such an advantage. And kudos to the CNCF for doing that. But another one that I think would maybe come up as well as when it comes to the virtualization of it is, especially in production environments, do you get the question, is there overhead to the virtualization versus bare metal? Like, what is the performance, or one of some of these, even if it's seamlessly available, do you get concerns around that?
100%. I think probably every second customer is asking about, is there a performance head? Where's the hook, right? What did I miss, right? And what we usually do is we pull up the architecture diagram. We explain how vCluster works under the hood for people that are really wanting to dig deep into this topic. And you'll see logically why there's no overhead just from understanding the architecture and from understanding how the inner workings of vCluster work. And that's usually enough. But some of our customers go all the way and they're like, logically that makes sense, but let me make sure and run some tests. So we had a whole bunch of customers with commercial engagements with us that as part of their POC criteria, let's say they are in Azure. It just happened like a month ago or so when a customer came to us and said, like, we benchmarked, 10 V clusters versus 10 AKS clusters. And the surprising result that a lot of these customers are actually seeing is that the vCluster performs even better in most scenarios than the actual cloud-hosted cluster. And the reason for that is when you're thinking about a vCluster, vCluster can have a different backing store. Each vCluster can have a separate one, right? So while your big, AKS cluster always runs with an etcd, your vCluster can run as lightweight as having a SQLite, but it can also be backed by a Postgres or MySQL database, also by an etcd. We also have a feature called embedded etcd, which runs directly inside of the pod, right, that runs the vCluster itself. So obviously we're like really, really close to the API server directly. And that's when people, when they run these kinds of configurations, they're actually seeing the vCluster has a better performance in terms of, you're shooting 1,000 requests at it. It's actually faster at reconciling resources and updating the state of that virtual cluster's control plane than a real cluster may be. And the other thing, when you compare, large multi-tenant clusters where you just use namespaces versus you use large multi-tenant clusters where you use virtual clusters inside of them, inside these namespaces, right? You see that the virtual cluster control plane is kind of like sharding your underlying cluster, right? So your underlying cluster's etcd is really complex, right? So every time you're writing something in that etcd, there's a whole bunch of like admission control and like all of these things happening, right? Versus in the vCluster, the scope is much smaller. In the end, again, it runs all on that large cluster, but that's an asynchronous loop. So for you to write the desired state into Kubernetes is much, much faster in a lot of cases with the vCluster, which is actually a surprising outcome. But again, some customers
Yes.
really validate it on their own.
No, I love that. And Let's also maybe go, could because at the end of the day, I mean, we would love Kubernetes to be the only thing you need, but as you mentioned, building these things it's a stack and it's a bunch of Lego blocks, or sometimes even some people say it's a house of cards because it tends to fall over pretty easily, right? Or the pieces are so dependent on each other, and so like when I think of like, I don't know, like Istio or Rancher or container hubs or like all these other things that could impact and be other parts of the stack, um, does the complexity increase? Does it decrease? Or is it the answer? It depends because like, is it a one-to-one ratio, one to many ratio? How does something like that get considered?
Yeah, I think there are obviously different groups of tools here, right? So there's the classical, cluster management software, something like OpenShift or Rancher or Platform 9, right? Like these kinds of tools. We kind of run really nicely on top of them because we don't deal with managing your cluster. You still, if you run just like with virtual machines, you still need something to take care of your bare metal machines, right? And that's a different set of tools than you need to manage your virtual machines. The same thing happens here, right? You need to manage your virtual clusters and you need to manage your real clusters. We're not great at managing real clusters. That's not what we're focusing on right now. We're focusing on the virtual clusters. And these other tools, right, that's a very established practice. There's lots of tools, even the cloud providers, right, Google with Anthos and all of these solutions exist, right? So you're still gonna probably rely on tools like that. Then you run your virtual clusters on top. In terms of the tools that run inside each cluster, that's where the virtual cluster architecture can really help you. Because when you have tools like Open Policy Agent or Cert Manager or an Ingress Controller, all of these tools, right? Prometheus, right? Everything typically runs in each cluster and it runs duplicated, right? So if you have 300 clusters, you're going to have 300 times Prometheus, 300 times OPA, right? Like all of these tools are going to be repeated. What we allow you to do with the vCluster architecture is you can run it in what we call the host cluster, which is the physical cluster that is managed by your AKS, EKS, Rancher, etc., right? You run only one Istio there and one OPA there, right? And one cert manager and one ingress controller and one Prometheus, right? And then you run 100 virtual clusters on top and they share these underlying tools. And there's some flexibility here as well because certain tools you want to make a shared offering to your tenants and tell them, hey, if you just need certificates, use the shared cert manager and just use it out of the box, right? We as a platform team or we as central IT are managing it for you. Here's how you provision that in your vCluster. You're not going to see that cert manager, but you're going to see the certificate resource and you can use it. And a certificate will be provisioned for you. But how that happens under the hood, you don't need to know. That's the beauty of it. You're using the Kubernetes API and the Kubernetes resources to get what you need. But the maintenance and the upgrade of that, underlying controller can be taken care of by somebody else. But the beauty of the vCluster is also that you're going to have these groups in your organization that are really, the frontier folks that want to innovate on the infra, that want to innovate on the tooling, right? And it may not apply to things like Cert Manager, right? I'm not sure if there's anything super revolutionary coming out, like nothing against Cert Manager. There's probably a lot of great developments that I'm not aware of. But, there's things like CI pipelines and how you deploy applications where teams are probably very opinionated and that's much closer to their, responsibility as application engineers. So they care a lot more about that delivery piece. So take a look at things like Argo CD and Flux and like these kinds of tools, right? They may want to run their own rather than relying on that shared one. So there could be a shared Argo CD, but some of your cutting edge teams are going to say, hey, this stable version that we're running is already 6 months old, and we would actually like to move forward with this beta or this release candidate, right? And install this on our own. The beautiful thing is in a vCluster, you can do that. That means some of your tenants are going to take the paved path and like the solution that is standard offered to everybody maintained by the central team. And then there's folks that say, we want to move ahead. We take the responsibility of running this on our own because we want to set we want to change how we're doing things going forward. And we want to be at the frontier of these things. And those are your most advanced folks. Those are the ones that have high velocity and really drive innovation inside the company. So you actually want to give them that opportunity, right? And with vCluster, it's really easy. They could have one vCluster with, the that they connect to the tools that they want to, just have from infra and from these platform teams. And then they have another vCluster where they run the experiments and the next generation of their deployment pipelines, for example.
Nice, nice. And one other, I feel like we're digging deep on architecture here today, but another last question, because it keeps popping in my head. I'm like, okay, what about this? And what about this? Um, let's talk about like control plane versus data plane. Because it's something like this, I definitely see consolidation of control plane being an advantage here, but then also too is like, is that in the cloud? Is it on-prem or is it both? And so tell everyone a little bit about the thoughts of handling the control plane for all of this.
Yeah, I mean, effectively what we're doing is we're putting the Kubernetes control plane inside a pod, right? So we're containerizing the Kubernetes control plane. And we're not the first one to do that, right? That's not the magic sauce behind vCluster. There's also tools like Kamaji, and there's tools like Hosted Control Plane. I think that Red Hat is working on. They do something similar. They put Kubernetes control plane inside a pod. How these tools are different, though, is they require you to connect nodes to this control plane versus, and that really segregates things. So yes, you don't have, 500 EKS clusters anymore, right? You can get away with one, and then you have 500 control planes running as pods, right? But you're still going to have completely separate sets of nodes for each one of these control planes, right? For us, what we're doing is we actually allow you to use the underlying clusters nodes and share them. So even two virtual clusters could schedule workloads on the same nodes if that is permitted, right? There's obviously certain things you want to put in place in terms of security guardrails and permissions. You don't want to have people launch privileged containers and then that node being shared, right? Because that gets really messy really quickly, right? Those are the kind of scenarios, though, that drive a lot of efficiency. If your underlying cluster owns all the nodes, and maybe you want to have some node groups, right, to segregate things a little bit, but you get a lot of efficiency by essentially allowing, the set of nodes to be shared across these sets of virtual clusters. And then really the state of the virtual cluster lives, as I said, in a separate, environment. It lives in etcd, it lives in a relational database, or it lives in a SQLite on a persistent volume, or if you want it totally ephemeral, just on the container store. And if you kill the pod, and it restarts, right? Kubernetes is going to restart the pod, and there's a brand new cluster, right? You lost all your state. And that may be okay if your vCluster is only supposed to run for, 3 minutes in a CI pipeline, right? We've actually seen that it's a case that I'm really excited about, ephemeral clusters in CI. Just imagine somebody has an application or controller or something that they want to run inside Kubernetes, and that is really dependent on Kubernetes, and you want to test it against 8 different Kubernetes versions and configurations and different clouds, right? Who would spin up in, 8 different EKS clusters for every pull request? Nobody, right? Because each one of these clusters is very expensive. It takes 40 minutes to start, right? But with vCluster, you can do that. You start, 8 vClusters. They start within seconds. It's just a container, right? The data store is going to be SQLite, super ephemeral, because you're going to throw this vCluster away, 10 minutes later anyway, right? You run your end-to-end test, your integration tests, right? And then you dispose these 8 vClusters again, and hopefully all your tests pass, then your pull requests can be merged. It's a really exciting case that really shows some things are not even possible with a traditional managed control plane in a cloud provider, but with vCluster they are, and they're really, really cost effective as well.
Yeah, no, that's fantastic, and I love to hear that of like, okay, taking the technology and figuring out new ways to use it. Um, Last architecture question, but this also comes into my mind when again talking about VMs back in the day, and let me kind of explain it. When VMs and VMware and virtualization technology in general came into being, there was always like, hey, what's the maximums? And because it was the maximum it would support. But then eventually we got to this place where we supported so many, the maximums became theoretical. But then what would happen is it's like, okay, how much, like take a host, how many VMs do you want on a host to run? Because what if you lose that host? And how long is it going to take like to reboot or restart or, cold start 100 or 200 VMs? And it became fault domains, became something you had to really design into. And certainly Kubernetes technology is designed to address that and address that at scale. But is this something, because you're virtualizing, you have to think about? Like, do you have to think about fault domains and maximums, or what is the thoughts on like the upper end of the technology?
Yeah, that's a great question. And I would say there are definitely certain limits to it, right? So for example, every virtual cluster, consumes obviously a pod in your cluster, and it consumes a service IP in your cluster, right? And maybe you're on IP4, maybe you're on IP6 for this internal address, right? Like there's definitely these types of constraints, even that Kubernetes itself does not scale infinitely, right? And certainly not without you taking very specific measures to get beyond a certain point of scale. So we're definitely constrained by the same scalability limits. I would say we've seen people run pretty successfully like 200-300 virtual clusters on the same physical cluster without having major issues, right? Obviously, you're going to be much more careful of monitoring all that fleet of virtual clusters, right? And you're not going to be manually checking things anymore when you get beyond, 10, 20 virtual clusters. Those are the kind of scenarios where also, kind of our commercial offering comes in, and where we can provide value on that and managing that fleet of virtual clusters. Um, but yeah, absolutely. You probably can spin up 10,000 virtual clusters on, certainly not a 100 node Kubernetes cluster in EKS. No, no questions about that. That's not
Yeah.
possible. There are definitely
Well,
limits like that.
it always brings up the old, just because you can do something doesn't mean you should do something, right?
Right. That's a good point. Yeah. I mean, at a certain point, you also probably want to think about, does that make even a lot of sense to have so many clusters in the same data center, on the same cluster, in the same billing
Yes.
account, right? Like there's other, organizational constraints that come to mind as well.
Yes, absolutely. So, final topic here. A little bit ago, back in KubeCon Salt Lake City, if I remember correctly, you announced vCluster Cloud. And as we publish this, KubeCon EU is coming up very, very quickly. So, is there anything you want to hint at or tease, or anything everyone can look forward to?
Yeah, I'm very excited about KubeCon, as I am about every KubeCon. We usually, as you mentioned, find a really nice feature to announce at that point. In this case, we're actually going to announce one really big integration, and one of the tools we just talked about somewhere in this episode. People may want to rewind. There's an integration in the mix that we kind of mentioned along the sides. But the other really big announcement we're going to have at KubeCon is regarding hard multi-tenancy. We were talking about, two V clusters can have workloads, containers on the same node, on the same VM. You obviously have to isolate, these pieces, and you can do that today. There's some really interesting technologies out there, things like Kata Container, gvisor, right? Those kind of solutions. We've seen a lot of them have issues, and they don't work as smoothly with technologies like vCluster, but also in general on a lot of public cloud clusters, and there are lots of constraints attached to it. So we're actually going to launch a new product that is designed to run. It can run without vCluster, but it is obviously very tailored to run under vCluster in a multi-tenant cluster, and it will automatically isolate containers running on the same nodes. And it is designed to run with CPUs, with GPUs, public cloud, private cloud, right? And we're really taking a big leap towards hard multi-tenancy, which is something really relevant also for production use cases to make multi-tenancy much more resilient, right? There's a spectrum from very soft multi-tenancy to hard multi-tenancy. The hardest way is just give everybody a separate cluster with bare metal nodes, right? And then the softest way is, hey, we're just going to have some namespaces, and that's our layer of isolation, which is really not a lot of isolation, or not isolation at all. And we're going to be covering this entire spectrum, right? Which is really, really interesting. And it's a nice follow up to what we already launched recently with our KubeVirt integration. KubeVirt as a tool to launch virtual machines outside from within Kubernetes, right, is one step to actually say, hey, let me actually provision a node for this V cluster specifically, right? But then again, you can't share the node again because it, belongs to that virtual cluster. We're now doing something in the middle to actually, do multi-tenancy on the node level. Very, very exciting topic. But that's, I probably spoiled too much already. You'll hear more about it next week at KubeCon.
Well, and I will simply say this as well. For everyone listening out there, just the subject of multi-tenancy alone is an entire separate podcast, and I would love to get you back on to talk about that a little more specifically at some point, because honestly, we've touched on it a couple times on the show over the years, but it's one of those things that comes up more and more, and especially the more you aggregate and consolidate all these sources, the more important it becomes. And I'm not going to throw that question on the end. I'm just going to simply say, hey, everyone, we need to get Lukas back on, and specifically for that topic at a later date.
I'd be honored.
So let's wrap that up there. So if anyone is interested, what's the best way to learn more about the technology, Lukas?
I mean, the GitHub repository, you find it, just search for vCluster on, Google or GitHub, you'll find the repository and all the source code. You can reach out to us via Slack. We have a very active Slack community. You'll find me there as well. Just, DM me. Like, I'm very happy to get into any of these architecture questions of anyone who is interested, want to nerd out about this. You'll find me next week at KubeCon, and obviously a majority of my team will be there as well. Come by the booth, check it out. And obviously, reach out on LinkedIn, on X, right? Just connect, send a DM, tag me or tag vCluster and Loft Labs in one of your posts. I think that's pretty much the ways to get in touch.
Fantastic. All right. Well, Lukas, thank you very much for your time. And for everyone out there, thank you very much for listening. If you enjoy the podcast, please tell a friend. Please leave us a review wherever you get your podcasts. And as always, if you have feedback, let us know. show@thecloudcast.net. On behalf of Brian and myself, thank you everyone for listening this week, and we will talk to everyone next week.